Good afternoon, everyone. We're continuing on with our work in expressions and functions and equations, kind of building on as we've been working on it. We're going to get into some function stuff today, a little bit about what they are, a little bit of a definition of domain and range, kind of leading into a heavy thing we're going to start working on tomorrow and Wednesday, leading up to our quiz on Friday. So a large portion of what we work with in algebra is working with expressions to then either determine whether it's a function or not, or to figure out some value of a certain variable given another variable. What a function is a function is a relationship between two things that result in one result for every input we put in. So we were working on Friday. We were working with something like we had 3a, let's say, plus b, and we were given two inputs for that a and b value. What we were looking at is we should only get one output for that. When we plug in two numbers for a and b, we're going to get one thing. What a relationship or a function does is kind of like limits the variables, or it makes the variables equal each other. So think about what we could say is we could say like y equals 3x plus 6. So what we're going to determine here as we're going through this is what can we plug in for x to get out an output for y. So if we plugged in 1 for x, we get 3 times 1 is 3 plus 6 equals 9, so our y value would be 9. That is one output, the one result for that input, because we can't get anything else if we plug 1 in. We're only going to get 9. So that tells us in this instance that y equals 3x plus 6 is actually a function. And we're going to find out going through this that anything y equals something, more often than not, it's going to be a function. There'll be some stuff we'll show you that's not functions, but here, that's going to be a function. And that is actually the one of the four ways we can represent functions as we go through this. We get the rule, which is this. We're going to be able to do it as a mapping diagram and a table, which you'll see at the end of this lesson. And then the other one is a domain and a range. It's more of a set of ordered pairs, what it is, rather than a domain and range. So I'm going to change this to a set of ordered pairs. Which is what we're going to work with at the end of this unit to kind of go over and set up two of the other three ways to kind of figure out what our relationship is. Okay. So what we're going to introduce today, though, is function notation. A lot of stuff you've seen in algebra, a lot of stuff you've seen as you're leading up to it has always been listed as y equals x. Do a simple equation. So we know y equals x. So when x is 4, y is 4. When x is 75, y is 75. When x is pi, y is going to be pi. That's what we're telling us. That's the relationship. What we also have in algebra, you'll see, especially in algebra 2, is we use a special notation for y. It still means y, but it's this f of x notation, where it's f and then in parentheses x. It's the same thing, that f of x equals x. This is exactly the same as this equals y equals x. Let me change that, not equals. I'm going to call it means. That's a better way to say it in this instance. So f in parentheses means y equals x. What the representation of the x tells us is it's a notation that as we're going through our algebra stuff, what we're going to end up seeing is you may see something like f and then in the parentheses a 3. What that means is we want to plug that 3 into that equation or that statement whenever we see an x. So in our example, y equals x, f of x equals x, when we get x equals f of 3 in parentheses, we know that that relationship is going to be 3. Does that make sense? It's a little tricky. I just want to make sure we kind of understand that, because it is a big part of what we're going to be working for and working on as we go forward here, is you're going to be seeing statements where f and then in parentheses 3, we have to plug 3 in for x. If we saw f pi, then we're going to plug pi in for x. If you see f equals 4, then you're going to plug 4 in for f. We read it that way. It's like f of. So when we read that f, sorry, we're going to call it f of x. Does that make sense? Okay. So it's kind of looking at an example. We have two examples. We have two f of x functions. We have f of x equals 3x squared plus 2, and we have f of x equals 2x plus 12. And we're told to evaluate the following functions when f is 3. So they're telling us in that notation, f of 3, we want you to plug 3 in wherever you see x in each of those statements. So what we do is you just come down and you do f of 3, and that's going to equal 3. We have an x, so we plug in 3. That'll be squared plus 2. Now we're just going to plug in and figure out, we plug it into our calculator, figure out what it is. I'm going to continue kind of here. I got 3. 3 squared is 9, so I got 3 times 9 plus 2. So now this becomes 27 plus 2, and that equals 29. So now we have f of 3 equals 29. Does that make sense? We're just plugging the 3 in, figuring out what the value is. Kind of what we went over with the evaluation, just making sure you're able to plug values in for the variables on Friday so that we're able to do this stuff as we go forward. Okay, next one, same thing. F of 3 equals 2 times 3 plus 12. 2 times 3 is 6, so we have 6 plus 12. Whoops, not 6 plus 16, 6 plus 12. Sorry about that. Six plus 12. Again, this is f of 3. So f of 3 equals 18. Again, that's all we're doing. You're going to be given some stuff today. Plugging in f of 3. What are the values as we go forward? Makes sense. Okay. Your turn. When you take a few minutes, go through, figure out what the f of x value is for the given x value. Plug your answers in the Edpuzzle, and then come back and check your work. Okay, so here's what you should have gotten. We're just plugging the letter we see, f of 4, so we plug 4 in for x in the first one, we get f of x equals 24. In the second one, x minus 2, we're trying to find the value at f minus 3. We get minus 3 minus 2 is minus 5. F of x is negative 2x. We want to find it at 5. So we plug 5 in, we get negative 2 times 5, or negative 10. And the last one, we get f of x equals 8, just like our original example. We told f of negative 8, so then f of negative 8 is going to equal negative 8. Does that make sense? Does everybody see that? We're good for this? Okay. One thing we're going to have to do as we move forward, I want to introduce it right now before we get into the whole thing, is we're going to be needing to fill out tables to help us with our graphing stuff. So here's an example that we're going to do. We're told f of x minus 4. That's our function. That's our equation, really. We're not quite sure it's a function yet. I'm going to tell you right now that way that it is a function, so don't worry about it. But here we're going to try to complete the table. So I've kind of filled out some stuff. I want values that we want to plug in for those x's. And we have our table. So it has the x value as a middle box that has nothing in it right yet. I'm going to show you what to do with that. And then it has the f of x, which really is what we want the output to be. This middle box, to help everyone out, as we've kind of set it up, we're going to write the equation in the top bar. 5x minus 4, that's what we're looking to evaluate. Now, each line what you're going to do is you're just going to plug in the value of x that you see. So I got 5 times 2 minus 4. That's going to equal, when you do that out, you find your value, you'll plug that value in the last column of your table. Next one, again, just simply 5 times negative 1 minus 4 equals 5 times negative 1 is negative 5, minus 4 becomes minus 9. Next one, 3. 5 times 3 minus 4 equals, that'll work out to be 11. And the last one is 5 times 6 minus 4 equals, this is going to be 26. That makes sense? Fairly simple, fairly straightforward. We'll learn later in the week, or maybe even after vacation, that we're then going to take this table and graph our equation in a graph to create the line of the graph. Make sense? To create a picture of that function. Okay, let's move on. Here's some for you to work on. It's 5 problems. There's 5 things to figure out in each problem. I want you to kind of go through. I've given you the same letters all the way through, not to kind of make it too crazy for you. So just use those numbers and see what you get. Again, for your Edpuzzle entries, what I'm going to do is I'm going to have you plug different numbers in for each thing to figure it out. Okay, so here we go on our example. I plugged in the equation in each box, top bar. I went through and figured out the values for each letter, -2, -1, 0, 1, and 2. And then we've gone through and figured out what our values are. Does that make sense? Everybody kind of match up your answers, make sure everything looks good. Okay. Again, let's move on and see where we are. Identifying a function. Like I said earlier, a function has one value of x. For every value of x that we plug in, we can only have one y value. There's no other way around it. We only have one y. So if as you're going through all these examples and you end up with some x value that may have 2 different numbers that can pop out for y, then you don't have a function. You'd represent it as not a function. And then we're pretty much just going to move on because there's really not a whole lot we can do it because you just don't know what you're going to get plugging numbers in. What we're going to use is we're going to use a table or we're going to use a mapping diagram to determine if it's a function, just to kind of help us out. I'll show you the different ways, each one here to kind of show you what to do. I always find it's easy with the mapping functions to definitely see if they're functions, just to kind of help it out. But we're going to start with a table. And the tables are really, when you're given an ordered pair, it's just as simple as an x and y table. We have our values of x, we have our values of y. We have 5 ordered pairs that they gave us. We have to look through and see what are the x values, what are the y values in our ordered pair. It's as simple as just going across and listing them. So in my example, I have x can be -1. When x is -3, when x is -3, my y value is 1. So that's the first line on my table. Go to the next one, -2, whoops, that should be -2. -2 and then 0. Then I have a 1 and a 2. I have a 3 and a -4. And then I have -3 again and a 5. So looking at it, it looks like I probably don't have a function because I have 2 values for -3, where x is -3, but my y values are different. So this really is not going to be a function, but we're going to use the mapping diagram just to make sure. Mapping diagrams are a little trickier because what you need to do is list the values from lowest to highest, is what I try to do. So in my example here, and then you list only every x just once. So what I'm going to do is I'm going to have a -3. So I'm going to start off with my mapping here. I have -3. I'll put a check mark over the -3. I'm doing all the x's first because it's just easier for me. I look, my next number is -2. So list them vertically. -2 collected. I have a 1. That's good. I have a 3. That's good. And I have another -3, but I've already listed that, so I leave that alone. And then I put a kind of circle those around. Same thing now I do for the y values. So these are my x's. Do the same thing for the y. I start with my lowest y value, looks like it's -4. That. Then I have a 0. Took care of that. Then I have a 1. Good. Then I have a 2. And now we have a 5. So I got all my numbers done. I circle these numbers. Does that make sense how we did that? We just kind of listed them vertically, put a circle around them, listed each x or y value once. If they appeared more than once, we just list them once. Now we go back. I'm going to change color here for a minute. Now we go back to each ordered pair, and you basically draw a line between the letters of the numbers of the ordered pair, the values. So my first value is -3, 1. Straight line, -3 to 1. I'm going to do each one of these in a different color. Green, this is going to be the green one, -2, 0. purple, 1 and 2, 1, 2. Let's go black for this one. 3, -4. And then I go to the navy blue, I guess, here. And then I have -3 again, but it goes down to 5. Sorry about that. So my -3 marks to 5. Now I look at this, and what we don't want is we can only have x having one value for our y. But I look at my list of x's, and I have -3 actually has 2 arrows or 2 lines coming off it. So that's telling me that it has 2 values for y. For that x value, there are 2 different values of y. So that's going to make this not a function, because I can only have one x for each y. So I saw over here, I had -3 listed twice. I had 2 values of it, 2 different values. It's okay if I had the 3 being mapped to 5 and 5 again on the table. That's fine. On the mapping, it would really just be one line because it's just -3 to 5. But I don't. I have -3 to 1, and I have -3 to 5. So when you look at it, I have my 2 lines for that. I have a line here. I have a line here. That is not going to work for that 3. So that means it's not a function. Does that make sense? Okay. Here's some for you. Take your time, do a table and a mapping function, and then let me know whether they were a function or mapping diagram, sorry. And then let me know if it's a function or if it's not a function. And then come back and you can check your work. Okay, so here we go. When I kind of looked it through my table, that should say mapping. So the table on the right, I had a 5 and a -2, a 3 and a -5, 2 and a -5, a 0 and a -2, and a -1, and a -3. So my table looks good because each x value is listed there once, each y value, even though there are 2 numbers graphed to -2 and -5, that's okay. They can have an x value can have the same value of a y value. That's fine. What we can't have is an x value having 2 y values. So y value can have 2 x's, but an x can't have 2 y's. So it's looking good. My mapping function, we still kind of see. I kind of made a mistake. I listed -2 twice. That was my bad. But again, I have 3 goes to -5, 2 goes to -5, but that's okay. So this was a function. Next one we go through and we kind of see we have -2 to 3, 0 to 1, 2 to -4, 3 to -1, and then 2 to 4. So we're looking like, okay, we have 2 2s. One's -4, one's 4. Probably not going to be a function. When I go through and I do my mapping thing, and I map it all out, I can see that, again, the 2 is mapped to -4 and 4, telling me that that x value has 2 different y values, which can't happen in a function. So that means it's not a function, and that's what we should have determined. Does that make sense to everyone? Okay. So that's today's lesson. There's a lot of homework trying to get this sorted out and kind of evaluating f of x, making sure you understand that. There'll be a couple of wrinkles thrown in, which I think you'll be able to understand. But I just want to make sure that you understand what that notation means, what function notation means, and what you're doing with the letters and the numbers inside the parentheses. And then there's going to be some examples of mapping problems and tables to figure out are they functions or not right now, which we're going to expand on tomorrow, leading up to when we actually start working with after vacation, when we start solving equations to kind of get some stuff going. So I hope everybody understood that. I will talk to everybody tomorrow and have a good night.